Companies in Australia, there are two really large ones and a few smaller ones. They're fully integrated generally, so they own their own breeder farms, they own their own hatcheries, several of them own their own feed mills. They usually have contract broiler growers, and they'll own the abattoir and the distribution chain, and they'll also produce further processed products. So one company controls the whole operation from top to bottom. So that gives you some advantages when you're trying to control. Things like foodborne pathogens. If you're working with tiers of ownership in those sort of areas, you've got to get everyone together to cooperate, or you're not really going to get anywhere. If we start looking at salmonella, you're probably aware there are lots of ways you can get salmonella into a poultry flock. It can come in through the feed if you're not careful. You can get it from any of the processes you do, from bird pickup to any time you visit the farms. Rodents and wild animals can bring that organism in quite readily. Biosecurity is only so effective against those sort of incursions, so it's a difficult one to just control with biosecurity. And the big one is this vertical transmission issue down here on the bottom, as you mentioned before. If you're getting infection in your breeder flocks, it's going to come through with Typhimurium mostly on the eggshell, with some of the other species or serovars that will go inside the egg. But you do get that transmission from breeder to broiler and down through the chain. And if you don't do something about that, you have no chance of controlling salmonella in your operation. So one of the things we do to control that is the introduction of vaccination, which I'll talk to you about fairly extensively. You can put things in feed, as you're aware, to try and decrease what salmonella might be in the feed, and also perhaps to try and knock out some of the salmonella that's colonising inside the chicken's gut. Some of these additives claim to reduce salmonella in the feed or in the bird, and also promote the growth of lactic acid producing bacteria like Lactobacillus or Bifidobacterium. Somewhat dubious with some products with that area. There are also oligosaccharides available, the beta-glucans type things, and the mannan products, which are claimed to bind to the salmonella in the gut and flush it out. And there was also probiotics that are claiming to decrease salmonella colonisation in the birds. And these sort of all work quite variably. Our approach was to follow the European approach with Salmonella enteritidis, and we started manufacturing a killed multivalent salmonella vaccine back in about 2003. And we administer that to our breeder flocks from the weak level right down to the parent level with 2 doses, given intramuscularly, usually around about 10 to 12 weeks and then 4 weeks later. Our vaccines are autogenous, so it's made from the strains and the serovars we're finding on our properties, and it's turned into an autogenous killed vaccine for our use. And we can vary the type of organisms or serovars in that vaccine as they change in the environment. Typically they always have Miriam to the B serogroup. We'll have 1 or 2 C serogroups, usually Infantis or Umbandaka, depending on what's common at the time. And we use an E serovar or Orion to give our multi-component approach to the 3 serovar groups that we're mainly concerned with, particularly B. There's no D serovar in there, so we're not concerned with enteritidis because we just don't have that one. Okay, so we administer that vaccine and we monitor it fairly, how it works. So administration sometimes is not perfect. So we have a very heavy breeder health monitoring program. So blood tested at very frequent intervals, and the age is down the left here. Blood samples done quite frequently. We'll also collect drag swabs by dragging a swab around in the sheds at various ages and culturing that for salmonella. The chicks, when they arrive, have the chick paper coming out of the boxes cultured to make sure we're not bringing anything in from the breeder above them. And we'll sacrifice 8 or so chicks that at about a week of age and perform a visceral emulsion, which means removing their total viscera and culturing that for looking for salmonella. So we're looking at that fairly extensively. Blood testing, we look at the response to the salmonella vaccine at 14 weeks and at 22 and 43 weeks. The 22-week one is the one we consider to be really critical. If we've got a good serum antibody level at 22 weeks, we've achieved most of what we need to do. Okay, we also look at water quality, as salmonella can come into your farm through poor water supply. Worldwide, there's 2 basic types of vaccine available for salmonella. So there's the killed one, which is the type we use in this particular operation. That's based on the Salinvac technology from Intervet and our MSD from Intervet, from the Netherlands. And they have a vaccine containing enteroviridis and typhimurium for the European market. In our case, we use the 3 other serotypes, the B, C and E combinations. In Australia, we do have an attenuated live ROA deletion vaccine. It's starting to get used in the layer industry a bit. Usually if you give it orally, you get fairly short protections, so we don't find it works that well long term with breeder flocks. But if you inject it, it's actually quite effective. So it's another talker. So how did we go? Back in 2003, we had about 50% of our breeder sheds full of, finding salmonella present. And we introduced the vaccine in late 2003 in all our broiler breeder flocks. And the blue lines are the amount of farms positive or sheds positive at each particular time each year. So you can see we're getting a fairly happy decrease in salmonella prevalence or detection in our breeding operation. You can see a couple of blips here. So we've got a blip in 2006 and another one in 2012. And they occurred when young chickens, they just couldn't find it quite extensively. But it can get into your flock by 7 days of age. Once it gets there, it colonises and spreads really quickly and gets into the seekers and stays there at high numbers. So we end up with things like 10 to the 7, 10 to the 8 organisms per gram of cecal content. So they're massively huge numbers of Campylobacter. Compared to salmonella, where you're lucky to have maybe 100 or 200 organisms per gram in the seeker. Campylobacter gets along very well with chickens. The chickens don't mind it, and it just grows in huge numbers. And it stays there all the way through the grow out, right up to early evisceration. And the only way we found to decrease that is by good post-harvest practices in the abattoir. So you can't decrease what's in the birds. There's no effective method that's achieved that as yet that I'm aware of. But we have to rely on decontaminating the carcasses during processing for Campylobacter. So general practices, we have very high standards in Australia, so we're very keen on keeping that level high. Particular attention on things that move between farms are quite a worry with particularly Campylobacter. Sanitation processes and control of rodents extremely important. Litter moisture will also, if you get very wet litter, you'll end up with increased levels of both Salmonella and Campylobacter, so we can maintain good litter quality as much as we can. And the other important thing is feed withdrawal. So when you're getting towards slaughter of the birds, we withdraw feed 12 hours. That's from the time the birds have their feed withdrawn until they're actually slaughtered. So it includes the time on the truck. And if you keep that within 8 to 12 hours, you minimise carcass contamination. Under 8 hours, you've got too much cut fill, sometimes crops full, and when you're eviscerating the bird, that can quite often contaminate the carcasses very heavily. If you go over 12 hours, you get fragility of the gut, and it's more likely to break when you're doing your processing operation. So again, you get more contamination that way. So very strict on the 8 to 12 hours window. We do use acids in the drinking water on the day the water's withdrawn, when feed's withdrawn, sorry. So that's usually lactic acid or sometimes the other organic acids. The other thing is we don't use antibiotics to try and knock out Campylobacter and Salmonella. It just promotes development of multi-resistant strains, and not something we want to do. Let's get into the abattoir. We use a HACCP program, or Hazard Analysis and Critical Control Point process, and following that through carefully and consistently gives us very good results. So we have several key control points in the processing chain that are very important for minimising the spread of both Salmonella and Campylobacter between carcasses, and they also work to decontaminate the carcass as well. The first one, basically you're looking at anything that touches the birds. So the first one of importance is the pluckers, or the defeathering unit. So you've got rubber fingers there that touch every bird as they go through. So you've got to keep them in good condition, maintained well, working well. And we have sprays, they exit that area with a chemical in them, usually chlorine. And we monitor that chlorine is at the right level when it runs off the carcass, which is 20 ppm. Second key critical control point are inside-outside washers. So as you come through after the evisceration process, there are washers that wash the bird outside and inside. Most of the Campylobacter and Salmonella is going to be in the gut, and if you let it out onto the carcass, you end up with contamination that way. So if you can keep the gut contained properly, you'll minimise that. And if you can wash the outside and the inside of the carcass, there's not going to be much in the meat, it's going to be all on the surfaces, and you can disinfect that pretty well. And again, we're looking at a chlorine compound usually as the disinfectant there, and that we're looking for 20 parts per million in that in the runoff from the carcass. And you've got to be generous with the water to knock this off, so we're looking about 3 litres per carcass to spray at that point. The third critical control point is our spin chillers. These are, if you're not familiar with them, they're long tanks with a big screw in the middle full of very cold water, ice water usually. And the birds go in and move through it. This is the chilling process. From the bird carcass, it's 41 degrees, you've got to get it down to 5, and it comes out the other end of the chiller. So the birds are moved through by the screw. We have a water flow that goes in the opposite direction to 7.5 to make the chlorine more effective. If you've got one of these and you're getting froth and bubbling happening in it, you have a major problem with bacterial contamination. So it's a fairly obvious thing to watch for. Offal we treat that's going for human consumption, we treat as carefully as we do the carcasses. So again, temperature control and washing in the chlorinated water is important. So you've got to get your everybody in the team online with these sort of things. So you need a great cooperation from your staff, and you need to keep them on top and owning the process that they're controlling. So there's automatic dosing and monitoring equipment on all the sprays and spin chillers. They have instituted now a automated data distribution system on iPads to the staff in key points, so they've got a real-time update on what's happening in the operation. They weekly and monthly send reports through to the general manager and the managing director. They've instituted compulsory internal audits, so they're constantly auditing the process and making sure it's working as it's expected to. And even they have voluntary third-party audits with people coming in from outside. Sometimes they're customers like McDonald's and KFC, so they're quite fastidious about what we're doing. So the pressure is on all the time to keep this working properly. If you get complacent, you will lose. So there's also risk profiling done on results as they come through, and they test carcasses coming out of the facility and monitor what we're getting at the end result. This was an external study done by AgriFutures, which is a semi-government body in Australia, works with all the livestock industries. They looked at 26 different abattoirs in Australia, poultry abattoirs in Australia, and looked at the level of Campylobacter coming off on the carcasses, and that's just ranked best to worst, but all of them are underneath the plus log 10.4 per gram of carcass, which is the upper level that we would be happy with. So looking at Salmonella and Campylobacter on our finished carcasses over the same sort of time period, the blue line is blue column is Salmonella, the red one's Campylobacter. You can see as we've moved along and worked on this, we've managed to decrease the prevalence of both those organisms on our carcasses quite effectively. So it does work, and it gets down to under this green line, which is the 7% of carcasses positive, which is the US standard to reach. So looking at human cases and poultry often gets the blame for human food poisoning issues, usually sometimes with justification, sometimes without. But this graph shows in each year you've got human serovars causing human salmonellosis, and the other bar is what we're finding on the broiler carcasses. So you can see there is some Salmonella enteritidis coming up, but only in the human populations, and most of those are attributed to people going overseas and coming back sick. So we don't get too much of that happening within Australia on its own. The red bars are Typhimurium, and you can see even though we've knocked down the Typhimurium in the broilers quite successfully, we're still getting quite a large number of human Salmonella cases. So they may or may not be associated with poultry. There are other sources where they can come from. This green guy, you notice he's only in the broilers and not in the humans. That's Salmonella sapphire. It's a B serogroup, but it's also a different subspecies of Salmonella. And it's very rarely found in human cases. It doesn't cause much disease in humans at all unless you're immunosuppressed. But it's the predominant species serovar in our poultry, which we were fairly lucky to have because it's not a particularly troublesome one, and it does displace some of the others fairly happily. We're sort of decreasing it as we go with the processes we're going through with all Salmonellas. We're also cutting out the Salmonella sapphire, but it's not one we worry about. So in terms of enteropathogen control, you've got to try and give the organisms as many hurdles to get over as you can to get through to your final product. There's no silver bullet, nothing's 100%, and you've always got to keep working at it, and it's a continual struggle to keep this under control. If you drop your guard on it, it'll come out.
It's 5 minutes left per given time.
Okay. So multiple hurdles. Vaccination against Salmonellas work very well. pH and temperature control and chemical concentrations in the abattoirs are important. There's always ways to improve. So we sample frequently, hygiene's very high, and we need staff to own the whole process. So that's our team at Berlin Laboratories. Tony Pavick's the tall guy at the back. Very hard-working group. A few references there. And we hope you might be able to visit us in Sydney in February for the Australian Poultry Science Symposium, which is a very good quality program if you can come. Thank you.
Thank you, Mr. Crook. Thank you for a nice presentation, information. And I would like to request the participants, the floor is open. You can have a clear information if you are in confusion. Please go ahead. Floor is open.
Thank you, Peter, for your nice presentation. I think it's very good. I'll be stealing some of your slides and repeating the same thing. Can you elaborate something on the laboratory system in Australia, like what is your networks with the government laboratories? For example, Animal Health Australia, AAHL, and your laboratory and the university laboratory and the private sector. Basically, which is not happening in Nepal. So that will be a very good lesson learned for us. Thank you.
Okay. So Burling Laboratory, which I was talking about there, is a specialised poultry diagnostic laboratory. It's owned by the broiler company and operates for its own purposes, also does outside work. We don't have much control from the government. We're allowed to self-regulate at the moment. There is responsibilities to report notifiable diseases and anything untoward, like if we found Salmonella pylori, that would be reportable. But pretty much they let us do our own job, and they also send a lot of their samples to that laboratory, because we're a bit more specialised in poultry than the government labs are. The government labs worldwide are rolling back, particularly against poultry, I found. So it's really required by the poultry companies to get their own laboratory system supporting them. Universities are usually specialised in particular areas. So Melbourne University does concentrate on poultry pathogens a lot, and they're a big diagnostic laboratory as well. The government laboratories will cover things like testing for avian influenza and Newcastle disease fairly consistently, and some of the other notifiable diseases like infectious laryngotracheitis. And we work together well, but there's no sort of real legislative requirements to do much other than for notifiable diseases.
A reporting system, you report to the
only on what they ask for. So Salmonella monitoring is all in-house, and that's done consistently by the companies. There was an Enteritidis Freedom accreditation program going at some stage, which we'll report all the results through to see if we comply with that, but it only concerns us if there's Enteritidis available. So we're a little bit at our own devices, really.
Any other questions?
South Asia is. So Nepal is part of South Asia. Nepal alone cannot control anything. So you need to have a multi-sectoral as well as the inter-regional cooperation. So to control the disease, that is the main strategy. Many of you might be knowing there are regional networks for disease control, such as Southeast Asia, East Africa, Southeast Europe, Southern Africa and Middle East. But which is not recently, there is a interim South Asia networks which consists of the professionals from medicos and the veterinary field. So such networks are very important in the disease control at the regional level as well as at the country level. This is another reality. Many of us know like 75% of all re-emerging diseases are originated from the animal origin. They are the zoonotic in nature. So when we talk about the zoonotic, I think in this hall, our dominant, we are all veterinarians. But this is not a single group of people can control the disease. But this is the starting point where you can see even SARS, MERS coronavirus, Zika, or even the Ebola, they are originated from the animals. More recently, you can see the tripartite, like, the wildlife, human health, and animal health. Out of that, the 75% we are calling a zoonotic disease, and almost 70% of those zoonotic are from the wildlife. So it's naturally, this is the claim for the Department of Livestock Services or the academia who are responsible for animals to go for these disease surveillance and have a very good communication with other sectors. So this is the important claim for our sector to justify that the virus is still in the source. The source who are working in the animal health or the veterinary field people. So the another, to justify to the policy makers, this is the economic impact in the global level. You see the more the circle, the larger the outbreaks. You can see the FMD virus in Taiwan, in UK, and H1N1, the highest, the economic loss. You can see the Ebola, SARS, and the H5N1. This is the global figures. So these are some of the estimates which shows most of them are the emerging, re-emerging zoonotic viruses which transmit from the source to the human beings. So therefore, I think you cannot treat anything. You have to be prepared for your response. There is a fact. If you are well prepared, you can save 5 times instead of starting just preparing the response. So the preparedness is the best option for veterinarian to do any disease control. So if you can get prepared, so you can control the disease at source, you can save some of the lives, and you can protect the livelihood, and you can reduce the economic losses. So again, I am not sure about, these are the key milestone for any veterinary schools or any veterinary departments in the world. So basically, prevent, prepare, prevent, detect, and respond. So if you go more details, there are, recovery state and the response, recovery state, and so this is the cycle of veterinary services. So if we are prepared and we apply these milestones in our regular program and the regular activities, and that is preparedness. Some of the, the single sector is not responsible for any disease outbreak. There are a lot of, these are all, proven facts that disease outbreak occurs because of your economy, because of you need more protein, you need more, you need better health. So these causes the emerging of the another, the new viruses. So solution cannot be found by one sector alone. This is the complex situation scenario. So the One Health is another area why you want One Health. So these are some of the facts and figures which justify the One Health operationalization is the need of today. So what is One Health? This is everybody in this hall, I think we know One Health, but operationalization of One Health is really complex. So it is not in the hand of one sector, one individual, one institution. So this is the responsibility of different sectors, and you can see the figure here. The three wildlife, human health, and animal health. The nature of the viruses. This is one of the example of avian influenza. How the virus spills over. This spills over where the preparedness is weak. It doesn't spill over in Australia. It spills in South Asia. So this is the problem because we have poor infrastructure, we have a poor knowledge on disease epidemiology. So these are the facts. So we need to prepare ourselves. If we are committed, if we can integrate our activities, then only it will be possible. There are a lot of areas where we want to integrate. Some of the areas, for example, technical area, my previous presenter was dealing on the salmonella, is a very good example of the food safety. The first opening remarks as well as the opening presentation, you hear a lot on the production and the per capita consumption. We didn't hear the quality consumption, the food safety issue. Food safety issue is the biggest challenge today. So any tourist, if coming to the Chitwan, whether he is really eating healthy meat, healthy egg, so this is the concern of the today's demand. So eating is one thing, and eating healthy food is another item. So the food safety, as well as apart from food safety, there are diseases which are it has shown some examples in some of the other regions where these are some of the diseases have shown that there is integration is very important. Integration is the proven theory. For example, avian influenza, when there is a bird flu outbreak, certainly the Ministry of Health and the Ministry of Agriculture, they come together. When there is no bird flu, I think it's very hard to come together. So that's the problem. So when you are prepared, and another is endemic zoonotic disease like brucellosis, rabies, and anthrax are some of the examples. Recently, this antimicrobial resistance is one of the emerging issue, and I mentioned is a food safety. Yesterday, we are hearing about the waste management in one of the presentation from professor from Assam. So waste management, they have started in their curriculum. So it is one of the One Health issue can be one of the example. So the operationalization of One Health approach is only possible when we work at local level, national level, global level, or regional level. So it's not developing the strategy in the paper. It's a operationalization at any stage. So what actually the countries are suggesting, the international partners are suggesting to the member states, why we cannot do in a small scale. For example, many of us, we know the Kathmandu Valley, the river of Bagmati, the people slum. The pig and human being, they sleep together, they eat together. So many of us, we know that, but we don't know what the viruses they are having. We don't know what the diseases they are carrying. So these are some of the facts where you can work at local level. And I think when we were the students, so the laboratory system, veterinary and medical were apart, very apart. Now they have come together. The human health and the veterinary health is the same. It's how you treat it. Can we have a single lab? Can we have a single department? So these are some of the challenges in the future. So unless and until we work together, we cannot control the disease, and we cannot help the global community that how to prevent the diseases. This is what I was talking, Peter was showing the critical control point. The critical control point, I don't know, the chicken was in the middle. How many arrows were there? There were more than 10 arrows. So that means the stakeholders, the stakeholder is not a single stakeholder. So you can see the stakeholder, where the veterinary service comes, you start here, farm level. Are you really doing the disease surveillance, disease monitoring, prevention control? Once you are sure that the farm practice is good, then you transport, then before slaughter, after slaughter, table, and then you process all the products. So these are some of the food safety One Health approach, farm to the table. But farm to table, how to operationalize? I think more than 20 years back we heard farm to fork, so farm to table. But what is the reality strategy for us to do that? So I would say, Department of Life Services will be responsible for here. Or maybe now somebody will be responsible here. Somebody will be responsible. The food safety part will be responsible here. So unless we work together, it will not be possible. Just slogan, it will be okay. But when you are really working in the field, it will be difficult. So one of the example of antimicrobial resistance, these are some of the facts. 700,000 people die each year due to the antimicrobial resistance. You can see that one of the bullet from Peter's slide is no antibiotics. So can we take that challenge? Can we do in Nepal? So what we study is without antibiotics people cannot survive, animal cannot survive, and this and that. But when you have very good farm practices, you don't need the treatment, you need the prevention. So these are some of the facts. And how many of you have seen this is the action plan developed by FAO? This is the global action plan developed by WHO. These are major global documents. And the country, when they participated in the global conferences, the ministers, the department heads, the secretaries, they committed, we will develop our national action plan for AMR. Many countries have developed, Nepal has not developed yet. So this is the reality. When you don't have any action plan, these are reference documents. And just for your knowledge, I want to show, like, FAO has 4 pillars, the action plan has, and the WHO has 5 pillars. How it is synchronized when you work in the field. For example, if these are the 4 areas: awareness, the evidence. Evidence is nothing but the surveillance, detecting and controlling the disease, and the practices. So when awareness and governance together, it will cover the information, education, and training of the global action plan. So this is somewhat is the synchronized understanding, and based on these documents, the country has to develop their own action plan for AMR. So I again say, like, India has already developed AMR action plan, but the Nepal still, I heard it's not approved yet. Some of the facts, medicines, many of us know, like, medicines, when they are very effective, during my grandfather's father's time, they are not effective now. When we are advocating, the people who are not a veterinarian and medical people, how to convince and one of the example is, when I work with the SARC director, who is not a veterinarian, they are the diplomat from the foreign ministry. Oh yes, my father has the same kidney problem, now any antibiotic in the Nepal is not working. So this is the reality why you and us should be very serious on the antibiotic use. Nobody is saying that you should not use it, but how prudent use of antibiotic is the very important. And so for that you need different regulations, and you need to ask our bosses, the high level, these are the problems if we use the antibiotic, where the impact on the production, food safety, farmer livelihood, and we are asking, like, we don't have any data at the moment, that the reporting system of how many antibiotics are used in particular farms, we don't have that data. So unless you don't have data, you cannot analyze anything on the antibiotics. So it is a global and multi-sectoral issues in terms of AMR pathogens, whether they are in the hospital or similar settings, or antibiotics in the farming system, and there is insufficient research or the information on the antibiotics. So I always say, like, this is a multi-sectoral problem. It's not a government responsibility alone. It's a responsibility of academia. For example, like, network of the universities, network of the schools, network of the laboratories, network of the epidemiologists. So such networks are lacking in our region. So how to build up? Somebody has to take the initiative. For example, One Health Strategy, Nepal Department of Livestock Service started the initiation, but it's still not happening. So it's like, if you talk about the partners level, for example, WHO, OIE, FAO, already they have developed the documents are there, action plans are there. So just taking base of those things, referencing these documents, we have to start something doing on the certain part of the country. Again, why we need the coordinated approach? I'll tell you, like, recently Department of Livestock Services has developed One Health section under the department. But how that the TOR of that particular section has to be very much coordinating with the multi-sector people. So that is very important. Unless you do, like if we talk in this hall on One Health, I think it's not really very good forum. Just one sector will agree on the veterinary field. When we bring both the sector together, then such type of realizations will be very important. At least you will not have a multiple reporting. You will not have a delivery system will be effective. I was talking to the national planning member. She is responsible for health. She is not responsible for. So she said yes. Anybody can come to me. I can bring the people from the member what we call that, the National Planning Commission member who is responsible for agriculture. We can bring these issues together. So I think somebody has to initiate. I don't know who is going to initiate. And certainly, the virus at source is the Ministry of Agriculture should take the lead. Antimicrobial. Some of the people say if you reduce the antibiotic, the problem will be solved, which is not true, it seems. Because the spread of resistant genes and strains are very much dominating factors. So what is prevention part? Is improving the sanitations, increasing access to the clean water, ensuring good governance system are some of the good example to reduce the risk. This is just to aware the audience here. How many of you know, the coronavirus is one of the emerging issues. So you see, existence of nearly 5,000 coronavirus in bat population at this moment. So we have Raute in Chitwan. They are very fond of bat meat. How many of you know that? So whether we have tested these bats in Nepal, whether they are really carrying some of the coronavirus, this is the international figures. But we know that there is Ebola was started from the bat. But we don't know human-to-human infection is occurring or not occurring at this moment. So these are some of the facts. The reality is, are we waiting for some outbreak to happen and then work over it in collaboration, or we start doing that? This is the main challenge. The viruses are there. I gave some of the critical control points. That is some of the points. Critical control points are the hot spots or some of the area where there are likely to be viruses. So I told the corridor of the Bagmati and the bats and the dense populations. So these are some of the area where you will have a problem with the viruses. See, these two papers, this was I received in my email at 4 o'clock in the morning today. See, the global burden of foodborne disease is unequally distributed. Low and middle income countries in South Asia, Southeast Asia are proportionally high burden. Again, what we are talking, when the countries are not developed, not prepared, this is happening. So, day before yesterday, another release, is a new World Bank report says the foodborne illnesses cost around 110 billion per year in low and middle income countries. So it's happening every day. We are not aware or we are not knowing those things. So this is just one example. This is just one example. I would say when it is a form of poultry, poultry food safety and diseases which transmit from the poultry to the human being are very good example for operationalization of the One Health. So at the end, what I want to say, whether we are prepared in the sense, this is very important: prevention, preparedness, detection, response, and recovery. some of the activity, when we started the job in the government system in Nepal, we never heard. And again, the university teachers are, you are there, we never read that. So that is the main problem. But the reality is, now, this is whole 3.1 credit course. This is whole, if you have special course for the students to learn about the prevention, detection, response, and the people will be prepared in the field, people will be prepared in the, when they are really in the job. So this is my request again from this, conference. People should come up right from the university as well as from the department level. Only that will be possible to prepare the pandemic or any preparedness. I think this is my end of presentation. Thank you. Thank you very much.
Dr. Bees? Now, the floor is open for questions. Please, if you have any queries, please go ahead.
Thank you very much for your wonderful presentation, sir. I'm recently graduate veterinarian from Rampur, and regarding the One Health, I have read One Health and zoonosis subject in my bachelor degree. But I have asked my medical friend who are also recent graduate. They don't know anything about the One Health and antimicrobial resistant concept. So this One Health approach is equally important for both medical doctor and veterinarian and environmental scientists. So does FAO have any program targeting to the medical doctor for awareness?
Very good. Very good. This is I told you, we have just started South Asia network, animal health disease, One Health disease surveillance network. They have already signed. The 2 members from 1 country, 8 countries have signed, and 1 from medical and 1 from veterinary. So already started, and we have already networking in the temporary basis, the Facebook networking, Google group networking, and many of you might be receiving my email every week and on disease status in South Asia. So I would like to, if organizer provides me the email, I can add some of you interested. People can be part of that network. So you know how we can bring that. But the domain, FAO has a domain responsibility with the Ministry of Agriculture. There is another partner, WHO. So we have at the country level, the WHO and FAO. At the regional level, there are WHO and FAO and OIE. So these are the 3 organizations, there is no problem. But when you come to the member states, now, members, I showed you, there is an action plan, FAO, action plan, WHO, it is synchronized already. So based on these documents, the country has to sit together and develop the document. So certainly the partner will be very willing to help if there is any such opportunity.
Thank you. If any, one more question. Okay.
Thank you very much. Actually, you have given the very nice presentation on One Health aspect. Lastly, you have given that it should be included in the syllabus. Suppose means the scientific community, they know how to prevent, detect, prepare, respond, and recover, as you already know. And lot of scientists already know these all things. Suppose the student or we all people know that about all these things. Do you think that by knowing all these things, can you implement all this program in our country? And that's one question. That's because I have heard that one proverb I want to tell you. The bottleneck is always at the top of boat. If you want to change anything in organization, you have to remove the bottleneck. So my opinion, even if you know all these things, you cannot, why this, all the things, this One Health aspect is going very nicely in Europe and America. Why not in underdeveloped countries?
Yeah.
Even if you know all these things, we cannot operationalize. So what do you think? That where is the lacuna? Where is the problem? And I think the problem is at the top of it.
Yeah. No, I fully agree. I cannot help on that. But it's like, one of the justification to the scientific community was to justify South Asia is vulnerable. That's why I showed that slide. Okay. If you are convinced, if the scientific community is convinced or not, first of all, if scientific community is convinced, I think right from Vice Chancellor, right from the acting Director General here, no, it's not just for the taking this conference here and forgetting and going back to your as usual business. The as usual business is the problem. You have to change your as usual business. Somebody who is responsible has to initiate. So I again will tell, unless, for example, why we are not, when we talk about the tourists, when we talk about the import, then only we talk about the good food, healthy food. When we eat ourselves, we don't consider ourselves good food. We can eat any food, right? So that's the problem. So you don't want to eat the healthy food. So I would certainly suggest that it is difficult to convince the policy level people. Like, nobody wants to take the authority from your hand. So the human laboratory certainly is not allowing. For example, we said, okay, you don't take the sample, but you can take the RNA extraction. When it is taken from whether it is taken from animal, it's the same. The RNA extraction procedure is the same. So this is somewhere, I don't like, it's a policy problem. It's a political commitment problem.
Thank you, Dr. Biswar. Now one more question in the first row. Pass the
It's not the question, I want to supplement.
Okay.
In the
Good.
month of July only, the WHO Net 80s, one program was initiated in IVRI, Indian Veterinary Research Institute, with the name INFAR, INFAAR. And that is for Indian Network on Animal and Fisheries for antibiotic microbial resistance. So, such kind of initiative can also be taken up in other parts of the country, and Nepal can be one of the candidates for that. This is my.
Thank you for compliment.
Thank you, sir. One more. Okay, this would be the last one.
Two more. One Japanese colleague.
Okay.
Thank you.
Because we are already
One of your
losing our
slides,
time.
in one of your slides, I saw it profitable to control rabies by mass vaccination. I think this is the most suitable and efficient way to control rabies. So if you have any other idea, I would like to know.
Thank you. Like, these are some of the examples from other countries. When it comes to the operationalization of One Health, the Bangladesh is doing well. Last week, the Parliament approved the act, which is Prevention, Control and Communication of Zoonotic Diseases. So, right from the politician level, they have already started. Bhutan is already doing that. The Sri Lanka will be ahead in terms of rabies control in this region. So it is just few examples where we have not started.
Okay, one more.
And I mean to say mass vaccination is the effective way, or is there any other way? to
This
control
thing
rabies?
we can talk in the launch time, please. No conversation.
Japanese guy. I was one of the committee to discuss food safety in Japan. I think you use still sulfapyristic.
Is that?
Sulfapyristic.
Oh.
Yeah, actually our government prohibited last draft the usage of sulfapyristic in animal production. You are considered to export or import meat, broken meat or something. In that case, probably you best so please consider that.
Yeah, thank you. I think what he is saying is some of the antibiotics they have already banned using in the animal feed and extra. And my colleagues from department will be able to respond those things in the future in the discussion. So thank you very much.
Thank you very much, Dr. Bit. Now I would like to request Professor Narayana Joshi to hand over the token of love to Dr. Bharat Singh Bistar. I would like to request our Vice Chancellor to deliver, to hand over the token of love to Dr. Bist. Please. Thank you, sir. Thank you very much. Now, I would like to request the next presenter to be ready. R. Athari. Now, this is the oral presentation, and you will be provided 15 minutes of time. And I would like to request you to be efficient for that time. Provide your presentation.
Thank you very much. If you can hear me, I'll try to finish in 15 minutes. I'll be rushing through quite a bit of things. As you can see, I work for Bioproperties. We make mycoplasma vaccines in Australia, and here I am talking about mycoplasma. Effective control of mycoplasma. I happen to work in India and other Asian countries ever since joining, so I've seen quite a bit of differences in the way we control mycoplasma. The major problems we see with mycoplasma is, as you know, respiratory problems or FCR problems, egg drop, and which encourages everybody else to have a reaction and start using antimycoplasma microbials. Speakers before me today have already spoken about the impacts of antimicrobial resistance. So one of my topic is mostly going to concentrate on Mycoplasma synovium. We have been using Mycoplasma gallisepticum vaccines for more than 10 years now, and everywhere in the world that we see, everywhere that I work, I see Mycoplasma synovium becoming a bigger problem than Mycoplasma gallisepticum. One of the typical presenting signs with Mycoplasma synovium, this is in commercial eggs, is glass top eggs. And this causes rejection of up to 4% of the eggs, and also in the breeders, if you happen to get it, will cause problems in your hatching. The easiest way to find and the cheapest way to detect the level of contamination in your breeders is by doing Aedes colitis check in pips. This is 18-day-old chicks. Doesn't cost you any money to do it, only you have to be trained well to do it. You look for Aedes colitis in the chicks. Mycoplasma is a disease that is vertically transmitted, and we need to stop that vertical transmission if you want to control it properly. There's a paper from Netherlands. I put it there for your reference. It is saying, is Mycoplasma synovium outrunning Mycoplasma gallisepticum? They have outlined quite a bit, which I'm not going to go and talk about. We need to find an answer for that. India, they've also found that Mycoplasma synovium is becoming a bigger problem. There's many papers. I'm just putting one of those up here for your reference. Sudan, same story, but here, Khalifa is very clearly stating that it is a very subclinical type of disease. Yes, we have started seeing that. We are not seeing joint problems, no synovium, but synovitis, but we are seeing subclinical Aedes colitis and also late embryo deaths in the hatchery. So if you are looking at something like that, investigate for Mycoplasma synovium. There is a paper 1996. He also in 1996 he said they were early